All right, so this last problem here was in the hard section of the answer of the question bank, but it's only in there because it had a lot more to it. I just took the part that had to do with chi-squared. So it says state the null hypothesis. So component of, so the type of the fitness test, so the component and the fitness level are independent is what we want to say for the null hypothesis. So null, over here, it's going to make this hypothesis is that is component of fitness test and fitness level independent. All right, so what's the null hypothesis? Show that the expected frequency of below standard performance in sprint is 8. So I got to really read that. So sprint and below standard, which is right there, is 8. So it's row total, so B, A, is 150 times 32 divided by 200. That's supposed to be 8, so let's see if it is. 150 times 32 divided by 8 divided by 200. So that the expected frequency of below standard performance in sprint is 8. Oh, it's 50. I'm sorry, 50 times 32. I've made way too many videos answering these today. 50 times 32 divided by 200. 50 times 32 divided by 200 is 8. All right. And they're never going to give you a question like that where it says show that it's this and it's not that. So if that happens, rethink what you did. Number of degrees of freedom. So I have 2 rows, 2 minus 1 times how many columns? 1, 2, 3, 4, 5 columns. So 5 minus 1 is 4. Because it's 1 times 4. Remember, the calculator will give you that at the end if you want to double check it while I do the chi-squared value. So it says use a graphic display calculator to find the chi-squared statistic. All right. So go back to my calculator. I go to matrix A. I'm going to try, if you did the last problem, I did it wrong and had to start almost over again. So I'm not going to do that this time. So edit, it's a 2 by 5 matrix this time. So 22, 10, 46, 46, 31, 41, 10, 6, 10, 9, 15. So there's my matrix A. I put my expected frequencies in the matrix B. Nope, that's matrix A. That's almost what I did last time. Matrix B. And that's not going to work either. Try this one more time. Matrix, edit, B, edit. 2 by 5. Done. Okay. Row total times column total divided by grand total. 150 divided by times 32 divided by 200. 150 times 16 divided by 200. 150 times 56 divided by 200. 150 times 40 divided by 200. 150 times 56 divided by 200. Not 150, we are just 50 now. 50 times 32 divided by 200. 50 times 16 divided by 200. 50 times 56 divided by 200. 50 times 40 divided by 200. 50 times 56 divided by 200. Okay, so there's that. You have to be careful. There's 10 of them. That takes a little while. So I'm going to drag and drop that over here. So then stat test, letter C, and we'll drag and drop that into there. Okay, so let's get matrix B and let's toss it up here. And if I look at those, I'm thinking that I did something. No, okay, I'm good. So I'm looking at them, and they're pretty close. So I'm thinking this is going to be independent for sure. All right, but let's see what we got. So there's our chi-square. It says the critical value is 9.488. So 9.48, sorry, 3.75 is less than 9.488. So accept the null hypothesis, meaning component of fitness test and fitness level are independent, which should make some sense because if you're going to pass these fitness tests, and I mean, we're talking special forces of the military, if you're going to pass one of these fitness tests, you're probably going to pass most of them. And if you're going to fail one of them, you're probably going to fail most of them. Just because, I mean, I would assume that if you're in the special forces of the military and you can pass you can pass more than one of the fitness tests, you probably can pass all of them. All right, so that's that. These take time to practice. There's, take the check-in, do stuff like that, and just make sure that we're all in a pretty good spot with these.